Now for these two examples, you're to simplify these complex fractions. Now remember, a complex fraction is when you have a fraction within a fraction. Now to simplify, it means you want to write it as one single fraction. Now for these examples, you'd have to remember that when you divide one fraction, let's say a over b, divided by another fraction, c over d, that's the same thing as the top fraction, a over b, times the reciprocal of the bottom, so d over c. So when you have 24 over 25 divided by 9 over 10, that would be the same thing as 24 over 25 times the reciprocal of the denominator, which would be 10 over 9. And then you see, when you're multiplying fractions, you see, okay, what can you cancel, and then what's left over. So for this one, when we say cancel, it means in the numerator of one and the denominator of another. So, or even the same one. So in the denominator of the first fraction and the numerator of the second fraction, those do have a common factor of 5. So we could cancel that common factor of 5. So this would be, so 5 left over there, 2 left over with the 10. And with the 24 and 9, those have a common factor of 3. So you could factor out that or cancel that. So you'd have 8 and 3 left over in that denominator. And then multiplying what's left, you'd have 8 times 2, so that'd be 16, over the 5 times 3, so that'd be 15. Now for the second example, we have 10x squared y cubed all over 3a to the 5th b, all over 25x y to the 4th, 9a to the 7th b squared. So that would be the same thing as your top fraction, the 10x squared y cubed, all over the 3a to the 5th b, times the reciprocal at the bottom, so the 9a to the 7th b squared, all over 25x y to the 4th. And then we see what could cancel. Well, looking at the coefficients first, the common factor of 3 cancels, and the top and bottom of the first and the second respectively, so this would still have a common factor of 3 for that one. And then the 10 and the 25, those have a common factor of 5. So cancel out the 5s, we'd still have a 2 for that one, and then a 5 in the denominator of the second. And now looking at the variables, let's see, doing the a's first, we have a to the 5th in the denominator of the first one, a to the 7th in the numerator of the second. So 5 of the a's cancel, and you would still have 2 a's left over. And for the b's, you have b by itself in the denominator of the first, and b squared in the numerator of the second. So one of the b's cancels, so you'd still have one b left over in the top. And let's see, for the x's, an x could cancel, and you would still have 2 x's left over in the top. And then for the y's, 3 of the y's cancel, and you would still have a y left over in the bottom. A little messy, so let's see what we have left over. So for the coefficients, we saw the 2 times 3, so that would be the 6. And then we'd have, let's do it in order, we'd have a squared and the b, and we'd still have an x. And on the bottom, let's see, we'd have just that coefficient of 5, and then the y. So that would now be simplified.